Data pervades all aspects of modern human life. The more data you control, the better decisions you can make. If you don't control the data, you can't control the market, and when you don't do that, somebody else does. Decisiv, a leading cargo and logistics company in North America, faced this exact challenge, collecting tremendous but inaccurate data on business operations over a span of 10 years. Decisiv met nothing but excessive storage bills. In this story, ClearScale presents how modern AWS services for big data and machine learning enabled Decisiv to solve these problems. Decisiv was able to start using data as a business asset with real value uncovered, accompanied by never before seen opportunities for growth. We will discuss how AWS Glue, AWS Lake Formation, and Amazon Athena allowed building the foundational architecture for their data used as ground truth in both current and forthcoming engagements. Next, we'll deep dive into the Amazon SageMaker stack and discuss ML ops and the benefits that you won't find in traditional solutions. We'll then see how this problem can be solved with both managed and custom ML models, allowing us to achieve a healthy balance between accuracy and cost efficiency. Our goal today is to discuss the latest AWS innovations in the world of big data and machine learning. My name is Kenneth Hendricks, and I will be your primary host for today's presentation. I'm a senior solutions architect at ClearScale and have been in technology for over 21 years. I spent the first 10 years of my career in healthcare IT doing everything from bare metal to browser. The past 11 years I've spent in architecture, helping companies solve real world problems with the power of technology so that they can focus on what matters the most, the business problem. I'm excited to see how powerful the realm of AI and ML are for companies today and what it will be in the future.
And I'm your other host for the day. My name's Suzanne Getner, and I'm a senior marketing manager here at ClearScale. I'm responsible for managing partner marketing at ClearScale, and I have over 8 years of experience in B2B technology, including 3 years of experience working for AWS partners.
ClearScale is an AWS premier consulting partner that helps companies innovate on the cloud. We offer a full range of professional and managed cloud services to help companies transform their applications and data to deliver business outcomes. Our professional services include application development and modernization, migrations, DevOps, managed services, IoT, data and analytics, and machine learning. We hold 11 AWS competencies, including data analytics and machine learning. For machine learning, we are the first partner in the world to achieve the ML Ops category. For today's agenda, we're first going to walk you through an AI ML overview. You will discover why you should use machine learning, when you should use it, and the barriers that you may encounter to adopting it. Second, we're going to talk about Decisiv's background. You will learn why Decisiv partnered with ClearScale to overhaul its data infrastructure and to automate workflows. Last, we will look at the solutions and benefits. This is a three-step solution to unify and normalize historical data, clear incoming data, then deduplicate it. When deployed with the right strategies, machine learning can increase agility, streamline processes, boost revenue, all by creating new products and improving existing ones, and also enable better, faster decision making. There's no doubt that machine learning and artificial intelligence, or AI, can help companies achieve more. In a recent survey by McKinsey, 63% of respondents reported revenue increases from AI adoption alone. It's also clear that adopters continue to have confidence in AI technology's ability to drive value and advantage. According to Gartner, 75% of enterprises will shift from piloting AI to operationalizing AI by the end of 2024, and according to Deloitte, 57% say AI will transform their organization over the next 3 years. You've probably heard AI and machine learning defined in a number of ways, so let's take a step back and review their exact terms. Artificial intelligence is a way to describe any system that can replicate tasks that previously required human intelligence. Almost always, this is related to some kind of complex decision making task where human judgment would normally be vital. Most use cases for AI are looking for a probabilistic outcome, making predictions, classifications, or decisions with a high degree of certainty. Almost all AI systems today are created using machine learning. Machine learning uses large amounts of data to create and validate decision logic. This is known as a model. The AI system feeds input data into that model, then the model outputs human life predictions or classifications. Essentially, machine learning is the underlying technology that powers intelligent systems. AI can be created without ML, but right now, it is the primary method for creating AI systems. Similarly, machine learning can be used for more than AI, but right now, the majority of ML is AI related. Optimizing business with new efficiency. Machine learning can be used to create greater efficiency through sophisticated demand planning and forecasting models. While this is true in almost every industry, retail provides some specific evidence. AI based forecasting is reducing lost sales due to product unavailability by up to 65% and resulting in 2 million fewer product returns every year. Smarter, faster decision making. Informed by data and analytics sources that grow smarter through machine learning, businesses and their workforces can make more informed, faster decisions that allow them to act upon opportunities sooner and get better results. Adding new capabilities to existing products. Machine learning can enrich existing products, improve customer engagement, and attract new users through deeper experiences. Inventing net new products. With machine learning, businesses can leverage data to develop revolutionary ideas and bring new products and even new categories to market. So, when should we use machine learning? Many human tasks, such as recognizing whether an email is spam or not, cannot be adequately solved using simple deterministic rule based solutions. A large number of factors and possibilities could influence the answer, leading to billions of lines of code that need to be updated with high frequency. When rules depend on too many factors, when they have overlap, and when they need to be finely tuned, it so becomes difficult for a human to accurately maintain the code of these rules. Machine learning approaches don't require the coding of actual patterns. They utilize algorithms to extract these patterns automatically. You might be able to manually evaluate a few hundred payments, for example, and determine if they are fraudulent or not. However, this task becomes tedious or even impossible once you scale towards millions of transactions. As a user base grows, it is no longer suitable to manually evaluate payments. In general, end users want to receive an answer on an order of milliseconds, not minutes or hours. These users will go where the speed and accuracy are. Machine learning solutions are effective at handling large scale problems with little or no human intervention. There are situations when you have an expert grade staff capable of processing requests manually, but it's the biggest expense item and a growth blocker. For example, you're assessing DMV forms for in state and cross state automotive purchases to determine their validity before sending it to authorities. The business processes are well defined, optimized, and serialized. It takes minutes, not hours, to thoroughly check the forms. Still, up to 90% of your annual budget is spent on those employees, limiting further expansion. Machine learning services, the opposite to human powered services, incur predictable fees with benefits like economies of scale, on demand pricing, and volume discounts. You've successfully prepared a well curated data set and even know the underlying problem. However, you don't see explicit patterns in the data preventing you from encoding those validations. For example, there are many typos, missing fields, and other mistakes in forms filled out by humans with no validation in place. You're sure that the data set is not good quality. You can visually inspect the data to identify this bad data, but you can't see the logical connections between good and bad records. Machine learning algorithms can find hidden links not evident to the human brain. Tools like interpreting tracers can even highlight how the ML model made one decision or the other. The world changes continuously, so does its problems. A problem you solved yesterday can mutate into something very different today, making an existing solution inefficient or sometimes even useless. For example, you have to process medical appointment records to extract diagnosed conditions, perform procedures, and accurate billing codes. New entities are settled weekly, and the existing rules are also not static. You can't make in time updates with a 24 by 7 by 365 fashion. Incorrectly recognized items lead to insurance rejections, potential fines, and legal penalties. Machine learning methods are intended to learn the data not only once but continuously throughout the entire life cycle. Production grade systems must have feedback loops to identify the very moment when the model no longer fits the problem, enabling small, iterative updates to be automatically applied just in time. So, what are some of the barriers to AI and ML adoption in the cloud? First, there's a lack of skills. Machine learning is fairly new for general audiences. Being restrained by the level of technological progress for decades, it was a highly academic matter with no visible application to the real world and business scenarios. Altogether, it led to only a few high quality trainings and courses that were domain specific, each with different topics covered, terms and definitions provided, and even contradictory facts given. There's an unfamiliarity with AWS. It's easy to master AWS, but for people who only have on premise experience, AWS can be challenging due to the different mindset. Pair this with the need to mix and match both on prem AI/ML stack and one of the cloud, and you can clearly see why the data science world is tough to break into and not prevalent in the market today. To elevate beyond this barrier, AWS offers a solid line of learning paths, certification programs, and enablement opportunities for both cloud services and ML as a science, all aimed at making your cloud journey a breeze, not a confusing, unguided experience. For cost management, keeping everything on premises allows you to think about IT resources as capital assets. You buy servers once and forget about them until time to decommission. This makes it an accounting problem, not a machine learning problem. With the cloud, you don't need to plan capacity ahead of time, nor are you constrained by current resources. When you want to update the hardware to the latest NVIDIA GPUs and avoid a proud fight with Bitcoin miners, just change the SageMaker instance type to the desired one, restart your cluster with near zero downtime. Then there's complexity versus customizability. Being limited by on premises expertise, IT specialists often fear the cloud as some insurmountable beast. However, AWS allows you to fine tune the complexity to customizability ratio of your solution. From managed AI requiring little to no ML skills to tools that design for your specific needs with algorithms unique to your use case, you're no longer limited to do it yourself matters. With this outstanding flexibility, you can combine multiple approaches into a single tailored solution. For compliance standards, with governments worldwide concerned about citizens' privacy and cybersecurity, companies are now obligated to follow strict regulatory requirements that vary amongst verticals. The industries where ML brings the most value, such as healthcare life sciences, fintech, and social media, must adhere to some of the most challenging rules. It was a common misconception that it's easier to achieve compliance by staying on premise. However, many AWS services are already certified for standards such as HIPAA, PCI DSS, and GDPR, requiring you to simply develop your solution accordingly and sign a business association agreement. This greatly simplifies the process of meeting and proving the security of your offering for these various compliance requirements. For security concerns, it's common thinking that the more control you have over where your ML runs, the more security you achieve. However, you'll never reach the same security that AWS offers by putting everything into the server underneath your desk. With years in cyber defense, thousands of skilled personnel, and data centers that can sustain nuclear annihilation, AWS helps you sleep good at night, not worrying about who could steal your data and how, which leaves your business ruined. Whether you're an established enterprise or a pre revenue startup, AWS gives you the same level of best in class security controls. For performance efficiency, people may worry that with so many people using AWS at once, their cutting edge ML models are left to struggle. AWS owns more compute resources than anyone else in the world, starting from 1 millisecond build serverless functions to monsters with terabytes of RAM, the latest NVIDIA GPUs, and highly specialized hardware like FPGA. With cloud provided elasticity, flexibility, and scalability, you merely define how performant your solution needs to be to meet its business needs with no compromises or hidden obstacles. With availability and outages, we know that everything fails. This is something you've likely experienced in technology more than once. Computers come with no guarantees of being crash free, and crashes can wreck your world. If your data center is in a hidden mountain village, you probably aren't as resilient as you'd like to be. One day soon, an earthquake could obliterate all of your users' data and bury your business. AWS is an alternative of a different caliber. You can spin up your solution in every corner of the world, obtaining the most negligible latency to end users and meeting data residency requirements. With an ability to distribute workloads across geographically isolated areas, even in the same region in some instances, your application will indeed survive the upcoming zombie apocalypse. Disclaimer, you can't currently upload yourself, so only your technical solution is safe from zombies.
The zombies are coming.
Decisiv Service Relationship Management, or SRM platform, is the foundation for more than 4,700 service locations across North America that manage more than 3.5 million service and repair events for commercial vehicles annually. This generates an immense data volume at high velocity. Because a lot of data activities are manual and error prone, the collected entities were of low value for analytics and intelligence. Also, it couldn't act as a single source of truth for any data driven process or operation. Some of the challenges that they faced is that their data was inconsistent, it was inaccurate, it was invalid, it was incomplete, and it was redundant. Data can be provided in different and often incompatible formats. For example, an organization's title can be stored as Some Company Ltd, Some Company Limited, or simply Some Company. This overcomplicates and can even make impossible analytical and operational queries. Analytical queries would be those where you're trying to aggregate metrics per company name, and operational would be more like when you want to index search on a company's name. Data can be entered correctly but lack essential attributes, making it ambiguous. For example, phone numbers are used in international and local formats, but without the country code, its source is not evident. A Canadian employee could be entering a phone number as they always have for the past 20 years, but with a recent acquisition, they now have offices in the United States to where phone numbers overlap with each other. And without this country code, it's not evident which office the phone number belongs to. Employees are responsible for all provided entries, and without strict policies, rules, and validations imposed by their organizations on these electronic forms, they could simply supply anything. For example, if a form contains an address field, without correct instructions, the office clerk is then up to decide whether or not they want to provide a main office legal address, for example, or one of their own workplace. Users can enter data of any type and format with all fields treated as optional. For example, one driver always offers the estimated delivery time, while another doesn't want to be obligated for anything. Even if the latter must provide such details per company rules, the presence isn't automatically checked, so human labor is needed to enforce the form's correctness. Some records could even be saved multiple times, either by mistake or by design. For example, the driver inputs the trip's closure records, so does their supervisor. For the computer, these two entities are different, leading to incorrectly calculated logistical metrics like delivered cargo's value in dollars over the last 7 days. Obviously, this problem can't be solved by applying a human workforce, too much money and too much time, or linear algorithms, too much coding, too much human factor. Therefore, it's the time when machine learning really comes out and proves its value. Before diving in too deep, let's discuss how most ML models are internally built. In terms of neurobiology, the model is a neural network, or NN, represented by the group of neurons and their connections. In terms of mathematics, it is a direct graph with vertices representing neurons and edges, or axons. Neurons performing similar functions are combined into layers. There are three main groups of layers: input, hidden, and output. Input layer receives external signals, for example, the DMV form, divides it into several subsignals, and sends them into hidden layers through axons. Like in biology, various axons have different weights determining the particular signal's probability to select this edge. Signals traversing throughout the neural network is not idempotent. When sending the same input into the model multiple times, you can receive different outputs, even if its chance is negligible. These weights directly reflect the data patterns learned by the model, however, being too cryptic for the human. While there is only one input layer, multiple hidden layers can coexist. For example, the VFM model would likely include about 100 layers. Hidden layers are called so because they can't receive any external data or be affected in any other way. At the model's end, there is at least one output layer. While the input layer's shape reflects the data to be passed into the model, an output layer depicts the data produced by the model. For the binary classification model presented on the screen in a reduced way, the output layer includes only two neurons, valid and invalid. In most cases, we don't have to build models neuron by neuron, axon by axon. There is a plethora of models with tailored architecture and pre-made layers to be easily integrated. When talking about training ML models, data scientists usually mean automated processes where special algorithms help the model learn the data. Machine learning models training can and likely would generate new and updated existing neurons and axons, but wouldn't introduce new layers. Some biology rules also apply here. More axons in the model means more accurate and smarter predictions that it can make. As in real world biology, the number of neurons doesn't contribute much to the model's metrics. For example, you can have 1,000 neurons with only 3 axons, making the model to produce the same results regardless of the input. ClearScale uses a time and material approach in order to bill customers for efforts actually exerted while achieving the business goals. ClearScale places customer satisfaction at the heart of everything we do, rather than contract negotiations. This allows for timely adjustment of scope, resources, and timeline while we learn from our incremental project results. In favor of agile methodology, and instead of over planning every single action, ClearScale outlines the primary milestones and major steps to get to the desired business outcomes. If certain steps are later found to be inefficient or no longer necessary, ClearScale is then positioned to make real time changes and openly welcomes change. We use a Scrum based delivery approach to accomplish this flexibility. At the start of each delivery group, ClearScale and the customer teams will meet to outline priorities and deliverables via a kickoff session and then gather requirements through interview sessions. These requirements are translated into high level features or tasks and added to the product backlog. The product backlog is stored on a Kanban board in Jira. Sprints are 2 weeks in duration and will prioritize a portion of the product backlog into the sprints backlog. At the start of a sprint, teams prioritize the sprint backlog based on the customer's priorities, ClearScale's resource availability, and the complexity of deliverables. Each feature accepted into the sprint then goes through planning, implementation, and review. Internally, ClearScale performs daily stand-ups as a sync and to identify roadblocks sooner rather than later. Teams meet weekly via checkpoints to discuss up-to-date outcomes, risks, and next steps. Knowledge transfer workshops are used at the customer's request to overview topics such as cloud economics, AWS Lambda, or React.js. These are accompanied by transformation acceleration workshops to facilitate the customer's transition to a cloud-native mindset. Upon the sprint's completion, teams conduct a retrospective to highlight accomplishments, failures, lessons learned, and opportunities for improvement. At the delivery group's end, a review of its entire scope takes place. It's followed by the customer's formal approval on whether deliverables meet business goals, technical targets, and other expectations defined during requirements gathering. When the product backlog is exhausted, all sprints are finished and delivery groups are closed. The customer and ClearScale perform a collaboration roadmap planning meeting to discuss lessons learned, compose the list of future potential enhancements, and start preparations for the next engagement. The solutions architect proactively captures these opportunities throughout the life of the project based on customer inquiries and the team's suggestions. Everything is detailed in Jira or Confluence and updated daily, including PM's meeting notes. Fuzzy matching is a type of probabilistic matching that can find similar objects with only minor variances. In the world of data, this means determining if two values are closer to each other than others. The measurement scale matters for each use case. For example, 1.1161 is near 1.1116 if we're talking about total profit per end user measured in dollars. But considering a distance between two atoms in physics, which is measured in nanometers, they seem to be completely different. In the natural language processing domain, where all text-relevant activities are, the similarity of two words is a distance between their form, meaning, or both. For example, nose is the synonym to nasal because they both have the same root, that is, edit distance. It is a distinct notion for the human, but not for the computer. Another example, excellent and amazing have the same meaning beyond a quality's extent difference, that is, the similarity distance. It's even less evident for a machine than words of one root. I'm sure you've all heard of the square peg in a round hole problem, or even the game called perfection. Fuzzy matching allows us to determine when something is similar enough to match them together, even when they aren't exactly the same. Before training a model with fuzzy matching, we need to gather historical data in one place and format to be further used as a single source of truth. Decisiv's data is stored in a cloud OLTP database on top of an Amazon RDS for PostgreSQL stack, which is also used for analytical purposes via read replicas. It's securely exposed to ClearScale's solution through an AWS private link connecting various in-cloud deployments via channels solely residing in the AWS barebone network. AWS Glue crawls the database via JDBC to ingest the historical data. Glue is an entirely serverless Spark platform with jobs written either in Python, Scala, or other JVM languages. Besides, it performs validations, for example, timestamp follows ISO 8601, and transformations, for example, aligning timestamps to the same time zone as data goes through the pipeline. This process is orchestrated by AWS step functions with the following benefits in place. State transparency, that is, an ability to inspect the pipeline state in general and single steps with input, output, and operational metrics. Sophisticated state flow logic. For example, run one mapper per frame in parallel and wait for all processors to be completed successfully. Basic data validations and transformations entirely expressed via step functions with no extra cost and services. For example, adjust the precision of float numbers. Automated exception handling, for example, halt on syntax error, but use exponential backoff to bypass transient network issues of data's external enrichment. It is the only stateflow orchestrator that requires no server provisioning, monitoring, or maintenance. Alternatives like Apache Airflow cause a lot of administrative burden, redundant operations, and high costs. After all the preparations, the data is reliably stored in the lake composed of the following: Amazon S3 to preserve data in Parquet. It achieves performant and cost efficient queries by not scanning the entire dataset and only scanning the ranges explicitly involved in them. Glue Data Catalog, compatible with various analytical tools with the Hive Metastore interoperability, for example, Amazon Athena, Redshift, or SageMaker. It inherently provides data governance, for example, find the right data to answer a particular question, and lineage capabilities, for example, find who, when, and how data changed or was used. AWS Lake Formation enforces precise security controls, such as prohibiting users from accessing accounting department columns while keeping the entire table intact. AWS managed OpenVPN tunnels enable secure interactions with the data lake regardless of applied access patterns. By the way, as AWS offerings evolve, we are going to apply the Delta Lake pattern using Apache Hudi or Databricks open source to receive mutating queries and full ACID support. The next kind of operations consist of two distinct yet still closely connected processes: ML model creation and prediction generation from these models. Together, they compose the machine learning operations, or in short, ML ops. Similar to how DevOps allowed us to transform the art of building reliable yet performant infrastructure into a craft, ML ops helps data science mature from the chaos brought by myriads of on premise solutions and become accessible to all businesses, including pre revenue startups and large enterprises. The world is not static in any sense, which is perfect for ML. As the domain evolves, trained models no longer fit the changing environment as they did upon deployment. In 99% of cases, models degrade over time, decreasing the produced business value as well as end user satisfaction. From our previous example, the truck form receives the new ID field, which has never been seen before by the model. In the best case scenario, the model would refuse to analyze it, and in the worst, it would provide incorrect predictions leading to ill formed decisions being made. This is how human learning works. If the programmer refuses to learn a new coding language version, they'd likely find themselves irrelevant one day because their skills are no longer suitable for everyday tasks. We saw this with COBOL, which was a must have a few decades ago but became superseded with much more robust and convenient tools. Because these models are not set in stone, we have to continuously retrain them with the most up to date data and occasionally change its shape to fit new game rules. The common lifecycle management pipeline consists of four steps: model development, training, inference, and evaluation. ClearScale delivered the first three as part of this MVP for Decisiv, with the fourth bullet planned for the next stages. As a first step, ClearScale data engineers created the base model and Decisiv engineers were able to tune it further. Using Amazon FSx for Lustre, we make data natively available from the Python code as is being loaded locally, getting up to 30 times acceleration. Amazon SageMaker Studio and Jupyter Stack are used together to supply data scientists with the modern cloud IDE. This enables engineers to create, update, and assess models via familiar tools while working anywhere around the globe with visual, programming, and CLI interfaces available. For the model's development, only the sampled data subset is needed, yet to prepare the model to deal with endless real-world scenarios, the training stage requires all of the data. Again, FSx for Lustre is leveraged as a storage adapter connected in pipe mode to achieve the maximum possible performance and keep local storage consumption low by downloading the relevant chunks only when they're needed. Additionally, SageMaker training instances are used here instead of notebooks. Being an asynchronous process, the model's preparation is conducted in a batch manner with all training logic encapsulated in Docker containers. If the model is natively available in SageMaker, we only need the job configuration, hyperparameter settings, and data source to be passed into the service. Otherwise, the data scientist has to manually compose an image. It must include only the bare minimum of components to keep the training time reasonable. AWS lends a hand with deep learning containers, tailored images pre-configured to work with SageMaker and industry-wide frameworks like TensorFlow, Keras, and MixNet. Beyond traditional training capabilities, Amazon SageMaker is equipped with dozens of robust technologies not available anywhere else. Model parameters are estimated from data automatically, and hyperparameters are set manually and are used in the process to help estimate model parameters. Hyperparameters highly affect traits like accuracy and performance, making their optimization vital for any production grade model. Hyperparameter optimization, or HPO, is often achieved in brute force by traversing through all the possible values and comparing changes in training results. Pair it with significant training time of ML models, and there wouldn't be enough effort in the whole universe to finish an HPO. SageMaker HPO auto-tuning is quite different. Rather than traversing all possible HPs, it focuses on the ones with the highest probability to improve models' metrics. However, it introduces a possibility of accuracy loss in 1/10,000th fidelity. Third-party tools support only a limited model set, but SageMaker allows you to use any metrics as optimization targets by publishing them from container into CloudWatch. As said before, the model's metrics are not static, making it essential to track how various inputs combinations affect training results. To achieve this, data scientists have been using Notepad.exe or a number 2 pencil and Big Chief tablet for a long time. It's a routine, error-prone, and unscalable solution. SageMaker Experiments changes the game by automatically catching new model versions either based on supplied data, hyperparameters, or algorithm implementation with no human intervention required. SageMaker Debugger is the only solution to evaluate ML models actively being trained as if they were a software application being compiled. You can pause training at any moment to inspect the achieved model's state, receive valuable suggestions on optimization, or catch bugs preventing training from being successfully finished. Finally, the model is deployed into the endpoint to be inferenced, or in other words, generate predictions. SageMaker rules this domain with inference instances. It's a fully managed Docker cluster with built-in load balancer in front of it. It avoids the need to manually monitor the underlying hardware so that you can focus on delivering value to end users. As with model training, you use either pre-baked containers or you create custom ones. In the latter case, you have to expose a web endpoint and tie it with inference logic. Inference Toolkit simplifies things quite a lot. It wraps your model into Docker with a web service attached. You are only left to write a few lines that pass input into the model and emit predictions back. With SageMaker, you decide whether to deploy one or multiple models per cluster, use onboard or remote GPU, and make the model monolithic or modular with pluggable weights, all to find the greatest balance between cost and performance efficiency. Every tool has the right place to be applied. With so many technologies creating various solutions, it's always complicated to say precisely which one will fit the customer's needs the best. It's all about trade-offs, really. You can't simply go to Google and download an easy-to-use and accurate, cost-efficient ML model for a cutting-edge problem. You're instead looking for the one which balances those qualities into an acceptable ratio. As such, ClearScale never sticks with a single design alternative and instead compares many, each with different metrics. To make life easier, AWS released a series of managed ML services, ones in which you do not need to design, develop, or deploy ML models. With tools like AWS Glue Fine Matches, you feed the data and tune a few settings, leaving all the heavy lifting for Amazon. Prepare the model, train it, and finally provision for use via standard REST APIs. Based on years of Amazon.com and AWS experience, those services give you levels of accuracy like you would never find in open source solutions. All the while, you aren't required to have years of data science expertise. At the same time, AWS gives you the best in class tools for custom ML models you build purposely for specific needs, as described in the ML Ops section. With solid infrastructure in place, we are ready to create the pipeline to suggest data corrections necessary for the sake of quality improvements. In normalization, columns of multiple formats are aligned with the most efficient one, removing the model's need to learn their differences. Google geocoding replaces arbitrary addresses with uniform representation and enriches them with metadata, for example, legal names of companies at the address given. Google's lib phone number does the same thing for telephone numbers. Next, AWS Glue find matches, finds duplicates, and similarities in data. It's pretty efficient in comparing records as compound entities where distinct fields aren't the only focus, but also hidden relationships between them. However, it performs poorly when it has to find issues in a single column. As such, we've launched a parallel branch with custom ML models. Find matches is used in both unsupervised and supervised modes. In the first case, the model is pre-trained on generic data of many domains. This allows us to get a taste of the data quality and decide whether Glue fits the domain at all. If there is enough historical data, Glue can be specialized for a certain domain, allowing it to better mine domain-specific insights. As a state-of-the-art implementation of fuzzy matching, Find Matches acts as a baseline in evaluating whether tailor-made models are efficient enough. It's fairly important to answer the question, do we really need this custom model if managed ML performs better without a need to maintain the underlying infrastructure and write supportive business logic? In a parallel branch, we deployed 3 custom ML models, each designated for a particular combination of input values. FastText is the fastest custom model in scope, benefiting from no need for historical data. Similar to Glue, it's trained on the generic linguistic data. It outperforms Glue in cleansing values of a single column. Still, it all comes with the inability to generalize rules spanning across fields. For example, if the delivery type is routine, it's okay for ETA to be null. XGBoost combines the best of both worlds by supporting compound rules and distinct columns at the same time. Besides, it's natively available in SageMaker, meaning no need for custom containers. Fortunately, XGBoost delivers the greatest accuracy to speed ratio, making it the top pick when no information is available to decide on the most suitable algorithms. Distilbert wins the game when accuracy is the main criteria, or if you're just looking for a tool with a really cool name. It needs hundreds of thousands of records for training, deals with the hardest rules in inference, but it could have you waiting until the next big bang. This state of affairs can be improved a lot by offloading Distilbert to run on GPUs instead of CPUs and gains significant performance boost. Because all 3 models play differently under various rule complexity, it's wise to run them together to achieve the best accuracy. The underlying state flow is identical for all models, allowing them to be run in parallel, keeping the flow duration equal to the slowest model, Distilbert. The only penalty is the costs. Models don't share training and inference instances, albeit normalization, features extraction, and post-processing steps are performed once for all branches. However, we still allow users to execute only the specific models to achieve the desired combination of metrics, for example, velocity versus accuracy. Altogether, this allows us to compare different models on the same historical data set and input values, which can be considered as a form of A/B testing. Initially, we've been supporting only one case, vehicle forms, with a rigid schema, for example, fields to be ordered in the same way across all invocations. But the customer provided great feedback and asked us to generalize the pipeline for any case in the cargo and logistics domain regardless of input. As a sound base for the solution's growth, we've made custom models to accept historical data in a find matches compatible format, eliminating boundaries across AWS native and custom models, as well as current and forthcoming ones. End users access that pipeline through REST APIs exposed via Amazon API Gateway. Access management is enforced via Amazon Cognito. Only the batch mode has been supported initially, but real-time mode has also been added as the usage patterns became more clear. Because some steps can be processed once for multiple records, the pipeline is extremely efficient in batch mode. There is a significant overhead in dealing with records one by one here. To keep the duration desirable, we train special models variants optimized for speed for the cost of a modest accuracy drop. Step functions bring an ability to select the execution mode when the API call is made, avoiding the need to maintain 2 rather identical workflows. By the way, beyond data cleansing, this pipeline can be used to search for records similar not only visually but also sharing identical or comparable traits. It is slower than traditional approaches like ELK, but provides more precise results close to what Amazon Kendra does. There were many business outcomes achieved through this project. The tailored machine learning pipeline that we created cleans, deduplicates, and improves data, whether it's needed in real time or in bulk. Data now is fairly consistent, accurate, valid, complete, and also essential. As Decisiv's business grows and the cargo and logistics domain evolves, more enhancement approaches, models, and algorithms can be incorporated with little or no modifications. Many business metrics were improved. Key staff were freed up from manual tasks to focus on more meaningful work. There was a fast ROI due to the high value of the solution, and speed and performance went up by an order of magnitude. This data platform is not a new solution for old problems, but a sound foundation for further growth. With customizability and extensibility in place, Decisive is now in control of how services advance. After the model is deployed into production, it's not the journey's end. As said before, the model's knowledge about the real world indeed drifts as more time goes from the moment of training. By monitoring the model's metrics as it is actively used, we can catch such divergence far before it would start affecting any downstream services or business processes. Monitoring can be established in both an automated way and one powered by the human workforce. In the first case, metrics are calculated automatically per inference result. For example, the model can't make predictions about Volvo trucks if it's never seen data from this vendor before. If the model monitor observes the endpoint performing worse and worse, it sends the model back for retraining. While efficient, automated metrics aren't always reliable. If the model doesn't know about its own incorrectness, it won't catch when retraining is needed. Under such circumstances, the human mind has to be engaged. Once again, SageMaker offers two similar tools: ground truth, suitable for data preparation or labeling, and A2I to deliver predictions even if the model is uncertain as of its rightness. In both cases, a person provides a forecast to be aligned with ones generated by the model, and other workers to find the best one. Another essential ingredient of this cake is the feedback loop, asking users' own thoughts about provided predictions. It consists of two planes: client-side user interface and server-side business logic. The famous UI case would be Netflix with a pair of thumbs up and thumbs down buttons right near the TV show recommendations. At Decisive, the most suitable approach is to trigger the up action when the user selects the predicted duplicate from the drop-down near the input field. Adversely, suggestions left out of the user's attention are treated as incorrect that trigger a series of thumbs downs. The provided feedback is preserved in the lake as a label taken into account at the next model's retraining pass and ingested into the model monitor, affecting the observed pipeline's metrics. For models with hot weights replacement, for example fast text, the feedback is learned by the model immediately without waiting for metrics falling below the configured threshold. Overall, the customer was so satisfied with our solution that we continued our engagement through ad hoc support services while planning out the next phase of the project together. This next phase is already underway and provides auxiliary services for the customer with the highest flexibility in terms of schedule, budget, and outcomes. A sincere thank you to everyone for joining us today. If you have any questions about the Decisive case study, ClearScale's machine learning services, or any of our AWS professional and managed services, please feel free to reach out to either myself or Suzanne at the emails listed above.
Before we go, just a quick reminder on who ClearScale is. We're an AWS Premier Consulting partner with 11 competencies, and we help companies innovate on the cloud. We've delivered more than 900 projects to over 400 customers, and as a cloud native company, we know it's more than where you build, it's about how you build. We're experts in transforming applications and data, not just infrastructure, to help companies accelerate time to market and reach new customers. Our services include application development and modernization, migrations, DevOps, managed services, IoT, data and analytics, and of course, machine learning. Thank you again for watching. If you have any questions about your AWS strategy or current cloud initiative, we encourage you to get in touch with one of our AWS cloud experts. Thank you again and have a great day.